that a lot of times students don't have time or they don't have an idea, and so we're really fortunate to have you submit a proposal and share your idea with us today. So originally Function was supposed to come tomorrow, but she's got I guess it was a game or sports evaluation, so she had asked to be doing it one day earlier today. So let's give Function a round of applause. We do have a strict 15 minutes, and then we'll have a question maybe at the end, and so I'll stop you if 15 minutes is not done yet, okay? Thank you, Function. You may start.
Okay, so hello everyone, and here is my IRP topic named High Biodiversity plus Low Cost, which is to propose a greening programming for the PKU campus using a mathematical modeling. And so here is the reason that I chose this topic, because nowadays everyone knows that people are saying about protecting our environment, and in the city we do it by decreasing our carbon emission, or we will do the garbage category, but most obviously is that we will increase our green spaces, the area of green spaces. So green space here means the area that are covered by plants. So we increase our green spaces by building parks and building reserves and planting trees around the road. However, there is a main problem that is a common problem for most of the green spaces in the city, which is that they are mostly monocultured. So monocultured here means that these green spaces are composed of one or very little species. So it is a very low biodiversity, area. And we know that the higher biodiversity of an ecosystem, the more stability it is. So low biodiversity here will result in low stability of these green spaces. And it will result in causing a high managing cost. So, which means that we will spend a lot of money to managing these green spaces. So nowadays, people are more and more aware of the importance of biodiversity in green management. And also, to increase the biodiversity, the things that we call wild grass play a very important role. The wild grasses, there's a kind of special wild grasses which are spontaneous species, which are similar to native species, and these species can grow very well in this area and without much care by people. So the managers of these green spaces are more and more aware of the importance of these spontaneous species. So they're thinking that if we can create the plant community with a lot of these spontaneous species, then we can highly reduce our managing costs. And this is what my IRP will focus on. And about the area which is the BDFA campus. So this is my research focus. And to date, we have already find and identified 65 plant species in our campus, and there are a lot of that is unknown to us now. However, you might think that we found our species in this lawn or this vast lawn, but it is not the case. Instead, we find most of our species on the edge of the campus where you might not even notice that there are plants. And also, we find some of the plants in here, this lawn, which is outside the dining hall. And you might ask that why we can't find a lot of species here and here, which are the two vast lawns. And this is because due to our observation in these years, we find that these two lawns will be replaced within 2 years, which means that we find that these two lawns have been replaced twice time within 2 years, which is a very high frequency. So because you know that if the soil of this place are replaced, which means that all of the wild grasses grow on there will be replaced by a mono species about that grass species. So it is a very great reduce of the biodiversity in these two lawns. And so my question here is that why we need to replace this soil so frequently? And I have a guess here is because well, simply these grass cannot grow very well on their own. And this might be similar with what I have just mentioned, that the ecosystem with low biodiversity has low stability. And this is why we need to replace these lawns very frequently. And so here I raised my research question. The first is that what plant species should we plant in our lawns to make it more biodiverse, to increase its biodiversity and thus increase its stability? And also because look at this table, and here are the list of the native plant species in Beijing. And you can see that there are a lot of kind of plants that are native to Beijing. So the first question is mainly about how are we going to select the plants that we're going to plant in here. And the second is that how should we plant them? Like how are we compose the ecosystem and where should we plant each plant? And my aim is to minimizing the managing cost at the same time maximizing the biodiversity. And so here are my challenges. And I have mentioned at the beginning that I want to use mathematical models to do this research. And I choose to use mathematical modeling is because you know that my research has a lot of numerous variables. So using a mathematical models can be an objective way for me to evaluate all the variables. Also, if I can build a mathematical model for our campus, and it means that I will find a kind of pattern of this community, and this pattern might, maybe the further researchers could use this kind of pattern to do a wider applications of these models. So meaning that it might have further applications in a wider area. And also, people now have already used mathematical modeling for plant community study. They have plant community modeling and biodiversity index modeling and like climate and plant association modeling. However, there are very few research that actually use mathematical modeling in the greening management. So, which is like, how are we going to plant the plants in our garden? And also, the research that focus on the greening model, like greening management, are mainly analysis, which is like evaluating how this place, how the biodiversity in this place and how are in that place. But there are very few research that actually gives suggestions for the greening management department that they can use the suggestion to actually programming their and planning their management. So my challenges here is that I want to combine these two things, like the mathematical modeling and the greening management, and I want to use mathematical modeling for to propose a kind of managing plan for our campus and to let them to better compose the ecosystem of the plant community on our campus. And for my schedule, the first step, I will try to build a mathematical model that can be an assessment of the greening management of our campus. And then I will try to optimize it and let it be a mathematical model that can actually propose the plans of actual greening management. And here are the exact schedule. And in this month, I will find sources and learn mathematical modeling methods and looking for database and maybe do some interview with the actual greening management department in our school and maybe also for Peking University. And in next month, I will start to build my first model, and this model will be a very simplified one with very few variables, and for which I will use to try to get familiar with modeling process. And for February to March, I will optimize my model and add variables in it. And for April to May, I plan to adapting my model into pediatric campus, because for April to May is where the plants are growing, so I can actually go to the campus and do some survey on it and collect some data. and at June I will present my result. So for the funds I'm need here is first is getting to the access of some database, because I need a lot of database for plants and maybe some satellite image and environment data. And also is getting access to statistical analysis tools and mathematical modeling tools, for example, MATLAB, SPSS, and so on. And these are some of these need us to pay to use it. And last, I want to try to since my research will result in propose of the managing plan of our school. So I want to try to apply my result actually on our campus, maybe like replanting a small area of lawn on our campus and try to grow some, try to rebuild the ecosystem there and see whether it will function like what my model predict. And that's all. Thanks for listening.
Does anyone have any questions that they would like to ask? Yeah.
So that is a really interesting proposal, and I think it's a very creative approach to addressing environmental problems on our campus. I was sort of one. I have sort of two questions. One is, have you already begun exchanging information with the campus environmental management unit on the campus to see if your research would be filling a gap, or to make sure that you're not doing something that they've already done, and have you worked collaboratively with them to develop your research, and also what input your faculty advisor has in the project?
Well, I haven't started to communicate with them yet, but I'm planning to do it because since I haven't found who are they, and Dr. Zeng said maybe I can first ask so to find who are they, and then because Dr. Zeng used to know of someone in that department, but he or she just leave the job.
Okay. Well, thank you very much. Was there a second part to that question? Oh, yeah, okay. Just working with your supervisor. How do you think your faculty involved will be able to assist you? That was a question.
Pardon?
How will the faculty involved with this proposal be supporting you?
I think like you mean Dr. Wei? Yeah, Dr. Wei will support me on like ecosystem part and the plant part, and the other Mr. He will support me on the mathematical modeling part.
Okay. Well, thank you very much. Thank you, sir, for your time.